friction, which can be written as mu s, will always be greater than mu k, which is nothing but kinetic friction. That is to say, when an object is in moving condition, you need not apply more force for it to move further. When compared to the object being in a stationary position and you have to make it start moving. Apart from this, we are supposed to study few more concepts called as coefficient of friction. What is meant by coefficient of friction is, imagine you have got a box. The box will have its own self weight and it will be called as W. If you imagine this to be the contact surface, at the contact surface you will have an equal and opposite reaction called as R. If this is the applied force P to push the box, an equal and opposite frictional force will be developed in the opposite direction, and let me call this as Fr max, that is maximum frictional force or limiting frictional force. Now, the coefficient of friction, that is mu, will be nothing but the ratio of limiting friction to the normal reaction. Now, if I have to nominate all the values written over here, limiting friction is denoted by Fr max divided by normal reaction is denoted by R. So, mu, that is the coefficient of friction, is nothing but ratio of limiting friction divided by normal reaction and represented by mu to be equal to Fr max divided by R. Now, static friction is indicated by the letter mu s and kinetic friction is indicated by mu k. From the previous sheet, we are very clear that mu s should always be greater than mu k. These two concepts you are supposed to remember all through while studying friction. Now, next concept is called as angle of friction, denoted by phi. Now, angle of friction is nothing but, if you have a box, it is very clear that this is the normal reaction R and this is the frictional force which we have denoted using Fr max. Because of these two forces, the resultant can be represented in this manner, and the angle formed between the normal reaction and the resultant of frictional force and the normal resultant will be called as angle of friction and denoted by the letter phi. That is, tan phi will be equal to Fr max divided by R. From the previous case, Fr max can be written as mu into R and denominator remains same. So I can cancel R and R. Thus, angle of friction will be nothing but the same as coefficient of friction, which is equal to mu. Now, next concept along with angle of friction is cone of friction. What is meant by cone of friction? If you imagine two-dimensional problems, in a two-dimensional problem, resultant, frictional force and their resultant, everything will lie in one single plane itself. Whereas when we start dealing with 3D problems, it does not lie in the same plane. Where does it lie? If this is the normal reaction, the resultant will lie at an angle of 2 theta with respect to the resultant. Now, how do I develop this? Imagine you have resultant over here and you have to imagine a cone being drawn at an angle of theta from taking this resultant as the radius. So when I draw it, a cone gets formed in this direction, and this is nothing but resultant. Now this angle will be called as, or the entire component will be called as, cone of friction of having angle 2 phi or 2 theta. Sorry, it needs to be taken as 2 phi. Next, we will be dealing with problems in our coming up slides. Thank you.